Hello, a short video here to talk about the nomenclature of transition metal ions. So when we last left off, we pointed out that you name ionic compounds differently depending on whether the metal can take one charge or multiple charges. And in this class, the elements shown in the periodic table below are the ones that you need to know can only take one charge. Otherwise, assume that the metal can take multiple charges and name accordingly. So how do you name accordingly? Okay, so the metal cations that can have more than one charge, you do this. You write the name of the cation, and then in parentheses, you put the charge of the cation as Roman numerals, and then you make a space, and then you put the base name of the anion followed by IDE. So this part and this part you were doing before, when we named ionic compounds in chapter 2, and now we're adding this bit, that if the metal can take more than one charge, you have to specify what that charge is. So some examples here. Iron can either be +2 or +3, and if the iron is +2, then it will form out an ionic compound with 2 chlorine atoms to make the charges match. Whereas if the iron is +3, it'll form a compound with 3 chloride ions, because each chloride ion is -1, the iron's +3, together that will neutralize the charges. So these are very different compounds, so they have very different names. And that's why you need this parentheses here, because the parentheses will allow you to unravel which compound of iron and chlorine you're talking about. So since this is iron 2, it's a 2+ charge, you put a Roman numeral 2. And then down here, this is iron 3 chloride, so you put a Roman numeral 3. Do note that there's no space between the iron and the parentheses that starts the Roman numeral. And when you're doing this in your homework, you can enter the Roman numerals as just capital letter I's. Another little thing is that all chemical names are lowercase. They're not proper names per se, unless if you're talking about a patented drug like Tylenol. But generally all chemical names are lowercase. Now contrast this to what we named before, metal cations that can only take one charge, and you just put the cation and the base name of the anion in IDE, sodium chloride. So some practice. If you're going to give the standard name of these compounds, what would they be? Okay, so the first one has chromium and nitrogen. Now, chromium can take more than one charge, so that means we need to put the Roman numeral after it. Now the game is figure out what the charge is. If you look at this, the nitrogen is -3, because that's what nitrogen always is. It's always -3 in an ionic compound. Since there's one chromium for one nitrogen, it means the chromium has to be +3. Now that we've deduced that, we can put the name out. It's chromium 3 nitride. Now in the example following, the chromium and the oxygen, well, oxygen's always -2, so in this case the chromium has to be +2, and it's chromium 2 oxide. Okay, and the next one, alright, a little harder to figure out the charges. You can, for simplicity, do the reverse of the charge swap thing, and you can say that you have chromium 2+ and nitrogen 3-. Sorry, those arrows probably got a little messy. So chromium 2+, nitrogen 3-, because you know nitrogen's always 3-, so that makes sense. So since this is chromium 2, it becomes chromium 2 nitride. Alright, for the next one, the silver chloride, well, silver is on that periodic table at the start of this video that shows that it can only take one possible charge. So even though it's a transition metal, you name silver without the Roman numeral. So it becomes just silver chloride. And then calcium chloride, calcium always is +2, and so you don't name it with the parentheses either. Okay, so you have to make this decision as to whether this metal can take one charge or not before you can put the Roman numerals in. This is important because if you put the Roman numerals in when you're not supposed to on a test, I take points off because that's the wrong name. Now we also have the power to be able to go backwards to take the name and find the formula. So zinc bromide. Alright, zinc is on our list of metals that only take one charge, and you need to know what that charge is. So if you look back at that periodic table, you'll see that zinc is a 2+. And then bromide, well, each bromine is going to be a -1, because that's where bromine sits in the periodic table. So that means you need to have 2 bromines for every zinc. So this is ZnBr2. Okay, copper sulfide. Copper is listed as +1. Sulfide, okay, that means sulfur. Sulfur is -2. So for this to work, you have to have 2 coppers for every 1 sulfur. Copper 2 sulfide, on the other hand, sulfur is -2, copper is +2, so they go together in a 1-to-1 ratio. Now vanadium oxide, the vanadium is 3+, the oxygen is 2-. And so if you write these out and do the charge cross thing, then you'll see that you get vanadium 2, oxygen 3. And that's it for now. Now we've added into our repertoire of things we know how to name, and we'll keep building on this throughout the rest of the first semester here. Thanks for watching.